In this video, we're going to go on to look at problem type Roman numeral 3, which is very similar to the types of problems we saw in Roman numeral 2, but this time we're going to have two different equations, and we're going to work together with two equations to find our solution. So, the long-distance rates of two phone companies are shown in the table. How, and we should add to this, how long does a call last that costs the same amount no matter which company is used? What is the cost of the call? Right, so the first thing we want to find out is company A has its way of charging you, and they're going to charge you 36 cents per call, which is once per call, and then 6 cents for every minute. Company B doesn't charge an initial amount, a connection charge, however that you want to label that. They simply charge 10 cents for every minute. And we want to find out for how many minutes will the cost of both calls be the same, or the cost of a call for either company be the same. And the way we're going to do that is by setting these two equations equal to each other. This is the cost for company A, and this is the cost for company B. When we set them equal to each other and solve for x, we'll find the number of minutes for which the cost of the call is the same regardless of which company we use. So in this example, we'll subtract 0.06x from both sides, and we'll end up with 36 cents is equal to 0.04x, dividing both sides by 0.04. We end up with x is equal to 9. And what is that 9? 9 is the number of minutes for the cost to be the same for both companies. Okay, so then the next thing we want to do is if a call is shorter than that, which company offers the better deal? And we can answer this in a number of ways. Well, first of all, we can see that company B charges more per minute. So eventually the cost is going to be greater if you talk for a lot of minutes for company B. So what we can do is pick a number greater than 9. Let's pick 10. So at 10 minutes for company A, we would get 0.36 plus 0.06 times 10, and we multiply that out. 0.36, 0.06 times 10 gives us 0.6, for a total of 96 cents for a 10-minute call. Company B, on the other hand, would simply be 0.10 times 10, which is $1. So we can see that which call is the better deal? For more than 9 minutes, company B is a better deal. And we could do something similar. The next question says, what if a call is, the second part should ask us if a call is shorter than that. So, and then the third part asks, what if a call is longer than that? So for more than 9 minutes, we've answered that part. For less than 9 minutes, we'll pick 5 minutes, and company A would be 36 cents plus 6 cents times 5, which is 36 cents plus 30 cents, or a total of 66 cents. Now for company B, it would simply be 10 cents times 5, which is 50 cents. So for less than 9 minutes, company B would be the better deal. And now I can see I made a mistake on the other part. So I'm going to change that. I said for more than 9 minutes, I had my arrow pointing to company A, but I said company B is better. I'm going to fix that. And now, for less than 9 minutes, it actually is company B is the better deal. Is the better deal. Okay, so we had two different equations, and we wanted to find out when both representing cost for a particular company, and we wanted to find out for how many minutes the cost would be the same. So we took those two equations and set them equal to each other, solved for x, and we found the number of minutes for which they were equal. Above that, one company is a better deal. Below that, the different company is a better deal. And so we used our algebra to analyze which company would be better and when it would be better. Okay, a similar type of problem to this also would be Roman numeral 3 type of problem, which again on the surface appears to be different, but underneath really is the same type of problem, mathematically speaking. And so we can use the same type of mathematical structure to solve problems that are very different, or different applications in apparently unrelated ways. Your business needs to print brochures. You call two different print shops about their prices. Each print shop charges a setup fee for preparing the brochure and then a price per brochure. So for company A, we would have a $50 one-time setup fee. We don't pay that for every brochure, and then $1.50 for every brochure that we print. We don't know how many brochures we'll print, but we plug in that number and we'll get the final cost. For company B, it would be $75 plus $1 for each brochure. Part A says the total cost is the same for each company. How many brochures is your business printing? So to find out when the two costs are the same, we're going to set these expressions equal to each other. We don't always set expressions equal to each other, but when we want to find out when the two costs are the same, then we set them equal to each other. So 1.5x is equal to 75 plus 1x, or just x. Now, we have variables on both sides. We simplify this by subtracting 1x, or 1.0x from both sides, same thing. And we end up with, 50 plus 0.5x on the left side is equal to 75. Subtracting 50 from both sides, we end up with 0.5x is equal to 25. Then dividing both sides by 0.5, we would get x is equal to 50, and the unit here is brochures. So what does this tell us? This tells us that if we printed 50 brochures, the cost will be the same regardless of which company we use. Now, part B says we decide to increase the number of brochures. From which company should we order? Now, you can look at the cost structure for each company, and you can see that company A charges less for a setup, but they charge more per brochure. So what will happen is that eventually the cost per brochure will make their cost greater if you're printing a lot. If you're printing a few, that will be the best deal. So let's pick a number again. Let's pick 100 brochures here. So, and we'll try the cost for each company. So 50 plus 1.5 times 100, and that would give us 50 plus 150, or $200 when we're printing 100 brochures from Company A. Company B would be 75 plus $1 times 100, and so that would be 75 plus 100, or $175. So the cost will be cheaper. So the cost will be less for Company B if we buy more than 50 brochures, or if we print more than 50 brochures. Okay, we have another problem from the picture packet, and I'm just going to put the solution here because I want to try to squeeze in another problem that will need some more explanation. So you can pause the video here, look at the solution, and then move on. And there it is. So take a look at it, and it's very similar to the previous problem where we have two companies. We want to find out when the price would be the same, so we come up with two expressions, set them equal to each other, and solve. So pause here and take a look at that, and then move on. Okay, so this came from Picture Packet, from the Picture Packet page 5, number 38. So we have this table and a graph below that shows information about students enrolled in Spanish and French classes at a high school. So in Spanish, there are currently 355 students, but the number of students is 9 fewer each year. So we're going to subtract 9x from that. Then the number of students in French this year are 229, but they are increasing at a rate of 12 students per year. And so we have our two expressions. We want to find out, I don't list the questions here, but the first question is to find out, and we could use the graph to estimate for how many years, or in how many years from now, will the number of students enrolled be the same in both classes. And we can see from the graph that that occurs at the place where the two graphs intersect, which appears to be at 6 years. And so then what we're going to do is we're going to use our algebra to show that this makes sense. If we want these two expressions to be the same, we set them equal to each other. And so we have 355 minus 9x is equal to 229 plus 12x. We're going to get all of our variables on one side. It'd be easier to add the 9x to both sides to keep that positive. We have 355 is equal to 229 plus 21x. Now we subtract 229 on both sides, and we end up with 21x on the right and 126 on the left. Dividing both sides by 21, we will get x is equal to 6 years. So in 6 years, we anticipate that the number of students will be the same in each class. Now, if we were to actually plug in 6 into both expressions, and we might write this something like S in 6 years will be 355 minus 9 times 6, and if we plug that in to our calculator, we'll get 355 minus 9 times 6, or a total of 2,076. No, that's not right. Well, that calculator is obviously not doing order of operations correct. We have to multiply 9 times 6, which is 54, subtract from 355, and we get 301. So be very careful with that. The French students in 6 years will be 229 plus 72, which is 12 times 6, which is also 301. Not exactly what you see in the graph, but we'll stop at this point.